Hello everyone. In this video I'll be talking about few circuits which are usually asked for entry level candidates, and these are very simple. You have to only comment on the gain, okay, and the only condition is you are not expected to write equations, nor you are expected to take more time. You just look at the circuit and directly comment on what is the gain of each of the circuits. Now I think they are very simple, and some of them may be a little tricky, but go according to your proper understanding of the circuit and try to solve them. Let's start with first one. You can just look at the circuit, what type of amplifier is it, and you can make one assumption here. You can always consider that that RO is really large compared to the drain resistance or compared to the source resistance. Okay, you can assume that RO is really very large. Okay, fine. Now, okay, what about this circuit? I will give you just 5 seconds directly. You will get 5 seconds to talk about gain of the circuit by inspection. Okay, I hope you all know this answer. This is a simple common source amplifier. Okay, and the total output resistance can be approximated to just RD. So minus GM into RD is the approximate gain. Why I'm saying approximate? Because I'm assumed that the total output resistance is just RD, because the resistance looking downward is really very high. Okay, fine. Look at the second circuit and take 5 seconds and quickly comment on what is the gain at VO. Fine, I'm sure you all have given it a try. The gain of this stage would be simply minus GM whole divided by 1 plus GM into RS, and here also the resistance looking downward is will be very high, so you can approximate it to be equal into RD. You can multiply it to RD. Okay. Okay, the third one. And for the third one, I would like you to think for some time and do not directly go and apply equations. Just think about what is happening in the circuit and comment upon the gain. You can take 5 seconds. Okay, I hope you have taken you have tried to solve on their own. What would be the answer? What do you think will come here? There is a constant current source. Okay, so it means that this constant current source will also flow through RD also, right? Correct, is it not? So it means that the voltage drop across RD is always a constant, and also the V out, the small signal V out is also the voltage drop across RD, right? Because this is my small signal output, because at small signal the VDD will be considered as ground, so the voltage at RO is RD is also the small signal output voltage. Also looking downwards, it is a parallel resistance, but looking downward, let's say the resistance is very high, so I just consider RD here. So what will happen, irrespective of any changes you do here, the voltage here is fixed. It means it acts like a fixed DC here. This node becomes a small signal AC ground, because the node voltage is fixed by this current. The current is fixed, and if R doesn't change, and we assume it will not change, because it is just a it's just a pen and paper kind of problem. So if RD is constant and I is constant, the voltage at this point is also constant, and VDD is also constant, so this node voltage will not change. So what do you think will happen? The output gain would be 0. Mm. On similar lines, try to solve the fourth question. The just that we have a current source now into the drain. Take 5 seconds. Okay, I hope you applied the same principle over here, and the same thing you can apply here. For example, just in this example, the constant current source created a constant voltage drop, and that's why I treated this as a AC ground, because this node doesn't move now. Okay, even though you apply a small signal, this node is fixed at AC ground. Similarly here, there is a constant current and there is a resistance. So this node would come and sit at AC ground, right? Because the voltage drop across this is always fixed. So now if this becomes an AC ground, this circuit is similar to the circuit with a common source. It is a common source amplifier with a current load. Okay, now assuming that the current source resistance is infinite, what would be the gain of this stage? It would be minus gm into ro. Okay, so many such questions would you can expect, okay, uh, which can be answered without taking much time, like just 5 seconds, and immediately comment on that. So for such questions, please take some time and do not directly use the equations which you remember. For example, let's take this circuit itself. People would try to calculate resistance looking downward, resistance looking upward, and all that. Okay, fine. So you can do that, but just if you have watched my previous video, the observation is the key. You have to observe the circuit and give some time to think, and later you can always use your mental memory based equation and use it, but first do a very good observation. Fine, that's about these 4 questions. You can expect similar questions. And another question which I would like you to solve on your own, for which I will not be discussing the answers here, but you can leave the answers in the comments. So let me talk about the questions now. The question, you can have a look at this circuit. There is a both are NMOS. Okay, this both are NMOS, and assume that this is a circuit where they're completely biased in saturation. So let's not get into whether it is in saturation linear. It is perfectly in saturation. Okay, that is our first assumption. Okay, and here also RO1 and RO2 are really very large compared to what, let's say it is very large compared to other resistance, like it can be greater than 1 by gm1, or it is greater than 1 by gm2. They are really very large. You can make some assumption based on this. Okay, is it okay? Is it fine? Now you have to comment on the gain, just like the previous problem. You have to find out what is the small signal gain at VO because of small signal input signal Vin. Okay, so for this I would not be giving any answers. I would first you can comment on this, but apply the same concept which you have applied here. Okay, so I think it must be a very easy problem, so I would like to leave you guys with this problem. Okay, fine. So I'll meet you in the next lecture video. Thank you.